Okay, hello, I'm Jen. I hope your laptops are successfully low on power so I can get your undivided attention now. Great. So I'm going to talk about things which even I considered impossible a few years ago. And I'm going to prove they are possible now. So it's basically talk about unicorns. It's a talk about turning IPv4 off in an enterprise network, Google Enterprise Network. It's a kind of continuation of the presentation I gave like 2-3 years ago when we tried it for the first time. So, first of all, why? Why would any reasonable human being would try to disable IPv4? First of all, because we actually run out of address space. We run out of private address space, which is much worse. You cannot buy it really, not enough. And shocking content, when you deploy dual stack, it does not solve your problem. If you deploy dual stack, you still need IPv4 everywhere, and you're still running out. So the only way was to start turning off IPv4 in one places and use it in some other places. And also, I am hands-on person, and I hate dual stack. It's nightmare to operate, right? You have basically two protocols, failure scenarios, unpredictable. Much harder to troubleshoot. So why bother? Let's try to get rid of the legacy protocol. Who cares, right? What kind of network we are talking about? We have a large corporate network, a lot of sites, let's say 4-digit number, and every site, like everywhere, we are not using DHCPv6 for address assignment, only for prefix delegation, and I'll talk about it. So basically, we assign addresses through Slack. Well, servers have static stuff, but again, this talk is focusing on offices, like places when people come with their laptops or have their desktops. It's not about DCs. It's not about like management part. It's like endpoints, desktop, laptops, phones. So yeah, they're using Slack. Every site has a device which does NAT 6.4, basically the same device which does NAT 4.4. And to access for only destinations, we obviously have to deploy NAT 6.4 and DNS 6.4. So yeah, we're doing NAT 6.4 in the edge. And in router advertisements, we provide hosts with DNS 6.4 addresses and with pref 6.4. So hosts know which pref 6.4 we are using for NAT, which is well-known prefix actually. We have a centralized DHCPv4 infrastructure, and you'll see why it's important. And also wired ports, they all have .1x enabled, and we put devices into different VLANs, like a lot of them based on authentication results. So previously, you might remember, I gave a talk about the day I broke all the treadmills, because when we tried it for the first time, we wanted to do a proof of concept. And for proof of concept, we selected the largest Wi-Fi network we have, the guest network. And we turned off IPv4 for Google guest Wi-Fi and for wired guest. And we created dedicated IPv4 enabled SSID instead, because we knew there are going to be some use cases for IPv4. We did it back in 2020. We did reclaim a lot of address space, which was very good. Management was happy, deploy people were happy because we were able to reuse that address space. But, well, it kind of worked, right? But we found out that having a dedicated v6 only network segment and dual stack network segment is not a good idea. It's very confusing for users because users come to on site, see different SSID, pick up the random one. As a result, they sometimes connect to dual stack SSID, even if the device can actually work perfectly fine on v6 only. For example, some phones, which work actually very well on v6 only, can still connect to dual stack. And they would consume my precious IPv4 addresses. It leads to high IPv4 consumption. And also, I do not have any visibility to problems. Why people join dual stack network? Is it just random choice? Or it's because something does not work, something I might be able to fix. Nobody tells me anything, right? Also, multiple SSIDs, Wi-Fi team hates it. And I realized that for wired network, I would not be able to do this. We have so many VLANs. If I start doubling number of VLANs for .1x, it would be like operational nightmare. So we wanted something better. What if, instead of doing dual stack and v6 only, we're going to do what I like to call IPv6 mostly? What if we can let devices coexist on the same network segment, and some of them can be v6 only, like new devices, which I know can operate in v6 only mode, and some devices, like old devices, would be still dual stack. How can we do this? Let's say a client can signal v6 only capability and say, hey, I can be v6 only if this network supports this. If it's just a legacy network which only has v4 or dual stack, fine, I can be dual stack. But if this network supports v6 only or v6 mostly mode, I am happy to be without v4 address. As a result, these devices can move between different networks and operate in the mode which the network expects them to. Because yeah, I was considering, can I just turn off IPv4 for corporate devices, but then as long as users go outside to public or like Starbucks Wi-Fi, everything would get broken, right? So how did we do that? We wrote RFC 8925, or you probably heard about this, especially if you attended tutorial on Monday, option 108. So we decided that the best way to turn off IPv4 is to use DHCP-v4. Because if you have v4 network, you probably have DHCP-v4. So how it works? In DHCP Discover, the client includes the option 108, which basically indicates the client capability to be v6 only. So if DHCP server is not aware of that option, let's say like normal Starbucks network, nothing would happen, right? The normal DHCP-v4 process would complete, everything works fine. If that device connects to my enterprise network, and it connects to the network segment which I already have converted to v6 mostly mode, then my DHCP server say, oh, for this network segment, I will return your option 108, which means shut up. Don't do DHCP-v4 for specified period of time, by default 5 minutes, be v6 only. And again, it only gonna happen for clients which support this. So for example, if you take some, I don't know, very old network device, nothing gonna happen, that device will get v4 as before. So now I can have two types of devices in my network and only some of them gonna get IPv4. So what do we mean when I say device can operate in IPv6 only mode? It's a kind of very vague definition, right? For some devices I know because I tested. My laptop been sitting on v6 only network for like 5 years, but I only use browsers and SSH. So for me, it's like everything works. But some people, you know, they playing some games and that stuff for some reason breaks and they're unhappy. Well, so practically, the only way you can say that device is capable of operating in v6 only mode if you know that the device runs 464xlat. Because mobile operators, they are way ahead of us in the game, right? They've been deploying v6 only network for a long time. Why? Because most of mobile phones run 464xlat, which means they run a special translation daemon on the device. And that daemon provides IPv4 address and IPv4 default route to applications. So if applications cannot operate without v4, what happens on v6 only network application? Oh my God, I don't have v4 address. I can't connect to v4. Go away. I'm not working. 464xlat tricks it and like, yeah, here is your v4 address. Here is your default route. And CLAT layer on the device translates the traffic from v4 to v6 and sends it over v6 only network as a v6 packet. And then it's translated by NAT64 device at the edge as normal. So yeah, that stuff works on mobile phones. And it also works on your MacBooks if you have something, if you have macOS 13 or newer. Obviously, it probably means that if your device can operate even without DNS64, strictly speaking, right, which is also good for DNSSEC. I know there are DNS people in the room. You should love this. So for me, practically, it means that I want devices which run 464xlat to send option 108. And obviously, yeah, I can manually opt in some devices without 464xlat if I want to. So project scope, what we actually did. We were disabling, we were migrating our network to v6 mostly, and the scope was all user-facing Wi-Fi and wired network infrastructure all across the globe. So all our offices, well, most of them. There are a few which I did not touch because they're very old. But basically, yeah, I want to cover the vast majority of user-facing VLANs. So devices in scope, all devices which you can send option 108. Currently, Android, iOS, and macOS, they send option 108 unconditionally. You just turn them on, option 108, they detect prefix 4, either through by receiving NAT64 prefix and router advertisement or by using DNS lookup of IPv4 only name. And they enable 464 XLAT and everything works. I also have selected Linux and Chrome OS devices as opt-in pilot when users can enable option 108 selectively and try it and disable it if they don't like it. But macOS and phones, they all like automatically opt-in, no opt-out mechanism. So how long did it take? We are currently at 90% of rolling out. I mean, 90% of all network segments. I'm counting VLANs where this is enabled. Fingers crossed, 100% will be reached next week when I'm back from RIPE. So we started with doing like extended pilot, first in 3 locations, like I started in Sydney where I was. Then we extended it for 1 month in 5 big offices. And then we flip the switch and say, okay, from now on, all new offices are turned on with option 108 by default, SAV6 mostly mode. And we started doing brownfield, retrofitting existing sites. And it's basically took us 4 months to do this. Yeah, so I started in March, and we really started in May doing the large brownfield rollout. So results, can't believe it. Fingers crossed, nothing wooden here, surprisingly well. So no real like showstoppers found. We found a few cosmetic issues. We found a few bugs in macOS, and thanks Apple. Apple been amazing. They've been fixing those bugs I'm reporting. So I would say Sonoma currently just works fine. Like we did find some issues for which we had to implement workarounds, and I can talk about this for hours. All right, but I only have like half an hour, so my apologies. I'm not gonna cover all war stories and funny cases we found. I have some backup slides so you can take a look at them. Maybe I have time for them, we'll see. So yeah, we were able to do this. Well, 90% done. I hate reporting stuff which is not 100% done, but sorry, we should have right meeting 1 week later. So yeah, average utilization drop, like 3-4 times on average network. There are a few networks which did not show much utilization drop, probably because there are a lot of Windows devices or Chrome OS devices there, but in average, I basically expect to downsize most of the subnets between like 2 and 8 times subnet size reduction. Yeah, so we basically start reclaiming address space and estimation at about like 300,000 addresses to be reclaimed by the end of the year. So this is not really a typical network because here is a really significant utilization drop. So you can see like it was, what was that like? Almost 40% utilization before, and it's /19. It's a really large office Wi-Fi network. So, and obviously I would not be able to downsize this because if I just make it /20, it will be 80% utilization, much higher than acceptable threshold. So after we did that, you see it dropped below 5%. So I just downsized it to /22, got 7K addresses back instantly. I'm very satisfied. So lessons learned. The most important lessons learned is that the only way to do this, like you can get much further with a good word and a gun than just with good word itself. So until you actually in a danger of running out of address space, nothing happens. I've been working on this for I don't know how long. We launched Google public DNS6 for what it was, 2015, 2014, because we needed that for this project, right? But until we ran out in like 2019, it never was a priority. Now it's like very important thing. Lesson number 1 is that I got a lot of surprises, right? 10 years ago, I was very unsatisfied with the quality of V6 in the network, but then I spent significant amount of time making it better. And I had a false sense of security. I was thinking, we've been operating V6 for so many years. My V6 network is perfect. It works as well as IPv4. Oh my God, how many things I found. Thanks to happy eyeballs, right? Nobody, like, you do not have a proper visibility to V6 issue while you have a safety net of IPv4. For example, like UV6 would mostly work, mostly like 98% of the time. Who would notice if your workstation or laptop, when it wakes up after sleep, would lose a DNS configuration for, well, until the next array comes? Maybe seconds, maybe minutes. Nobody would notice it as long as you have V4. But when you turn off IPv4, oh, that's all fun started. And again, users do not report the issue. And all those issues on endpoints are really hard to detect and test, right? Because sometimes it's a race condition, sometimes it depends on what users do, right? So it's not something I can easily test. And as a result, when you have V4, nobody reports anything, nothing gets fixed. So yeah, so if you think your network is like V6 ready, well, you might reconsider. So, some discoveries we made. If something looks like a host, behaves like a host, is it actually a host? Yeah, I was thinking so, right? People put some devices in the network, like some box with some screen even maybe, and it gets a IPv4 address over DHCP, gets IPv6 address over Slack, and then actually we discovered that when we did V6 only guess, so it was option 108 yet. We found out that it's actually a router. Might be a router, might be something inside. I actually had to take a screwdriver, open that box, and found the OpenWRT box inside, a tablet, and a few other things connected. And for me, it was a host, right? No. And as soon as I took away IPv4 from that thing, right, everything got broken because this device cannot extend the network anymore, right? It was using NAT for IPv4, but it was not able to extend V6 connectivity downstream. Well, obviously, we can use 464X LAT here, but is it a good thing? Do I really want all these tethered systems to stay V4 forever? No, we actually want IPv6 there. So what we are doing, we using DHCP prefix delegation to give prefixes to endpoints. It was some discussion at IETF. It's not strictly speaking a host anymore, right? It's a router. The line between host and a router is now so blurred. Like my phone, is it a host or a router? Strictly speaking, it's a router because I have my laptop tethered to it. Chrome OS, and I'm going to talk about it later, right, have like 5, 7 VMs inside. Is it a host or a router? Tricky question, right? So let's say a node. Something which looks like a host, okay. So, I have so much time. We can talk about this more. Good. Yeah, so this is a slide which actually summarizes 1 hour talk I gave at IETF. Yeah, so we can talk. I have some backup slides. Yeah, so first of all, surprisingly, the biggest issue we discovered, biggest in terms of number of support tickets open, was people, oh my God, I came to the office and I cannot connect to Google Wi-Fi anymore. Why? Because they had IPv6 disabled on their laptops. Why they had IPv6 disabled? Because for years, support people were saying, you have a problem, right? Did you try to disable IPv6? Oh, it helped. Ticket closed, problem solved. I asked many times how exactly we are going to re-enable that thing back. Nobody cared. Well, until we suddenly stopped providing IPv4. So yeah, so we had to use a script to go to every single corporate device and re-enable IPv6 just to make sure it stays enabled. So fragment extension headers, so I love extension headers. They are actually used. I know some people think they don't, but they are. There are 2 very useful extension headers in the wild. One of them is fragmentation. Okay, let me find supporting slides for this. Yes, so fragmentations, obviously. For end users, it mostly DNS and some other UDP applications like Mosh, for example. If you're using Mosh, you might get unpleasantly surprised if you block in fragment headers. ESP header, it's actually IPsec, right? Which means VPNs and Wi-Fi calling, right? Wi-Fi calling. Your phone actually established IPsec channel to a voice gateway. And if you're using IPv6, right, you need to remember that you need to permit not just TCP, UDP, ICMP, but also ESP headers. Yeah, we found some actually funny issues on some platforms. Some NAT64 devices were really happy doing NAT64 unless IPv4 packet was coming with 0 UDP checksum, which is perfectly fine in IPv4. Well, some NAT64 devices start putting some garbage inside, which made endpoints very unhappy. So some other devices decided that, yeah, I'm a stateful firewall indeed, but when I'm permitting outgoing ESP traffic, I'm not going to create any state for return flow because for state, I need port numbers. No port numbers for ESP, so no, just drop it on the floor. Well, that was easy to fix. Fortunately, it was just an explicit rule, but still. Yeah, fragmentations. Surprise, surprise, IPv6 header is 20 bytes longer than IPv4. So inevitably, if your NAT64 device receives a 1500 bytes from internet and the F bit is set to 0, NAT64 device will fragment it. Well, unless you have more than 1500 MTU in your V6 infrastructure, but I know that some endpoints don't really like getting packets of bigger than 1500. So yeah, so what's gonna happen? Your NAT64 will create 2 packets fragmented with fragment headers. And by the way, some devices are not even using 1500 as a packet size. They're using 1280 as a default fragmentation size in this case. Fortunately, it's configurable. But again, it's something I was not aware until people started to complain about some packets disappearing in the wild. And again, like for endpoints, as I say, it's UDP applications. If you start using V6 for network infrastructure, radios becoming a problem, right? Because radios as DNS wants to get an answer in one packet. And if you start using certificates for .1x, well, packet will be definitely bigger than you can fit into MTU. Okay, yeah, I talk about this. Let's go back to summary slide. So yeah, talk about NAT64. Oh yeah, this one probably deserves much longer discussion. So I start getting complaints that Chrome OS devices having connectivity issue and kind of strange connectivity issue. It's not like nothing works, which is normally easy to troubleshoot. Some applications losing connectivity from time to time. What happens is, as I say, Chrome OS, it's actually a very complicated thing. Inside, it runs a lot of virtual machines, namespaces, a lot of them. And each of them obviously get an IPv6 address, more than one sometimes. So you can easily see your Chrome OS laptop using a Chromebook, using like 10 or even 20 IPv6 addresses at the same time. Wireless devices are trying to be very, very helpful. They're trying to do neighbor discovery proxy. They're trying to respond on behalf of other devices. And for this, they keep in a table which client has, using which IPv6 addresses. Size of the table might unpleasantly surprise you. Some vendors use like magic number 7. And after, oh, you've seen more than 7 addresses on a device? And okay, I've seen 20. And this is actually, and the problem is, right, troubleshooting this is a nightmare because when n+1 address appears, it just fails to install it into the table. So everything works except this one address. Troubleshooting that stuff was fun, really, right? And again, then some addresses disappears from the table, that problematic address started to work, and some other addresses fallen off the network. So job security, I was very busy for a while, yes. Obviously, and also, let's say you have a VXLAN infrastructure, which probably means every address is a route. Now you suddenly have 20 times more routes in your routing table than you planned. And this now translates to money because it's completely different hardware now. So kind of doesn't scale very well, right? People start complaining about that IPv6 thing because it's very expensive. And this is actually a very similar problem to one I had on the slide before about device extending connectivity behind itself. So what we're trying to do, and there is a work in progress, is to start delegating prefixes via DHCPPD to such devices. So instead of maintaining a huge route neighbor discovery cache and wireless table, which has 10 or 20 or 30 addresses per device, we only need to maintain a single route and a single entry for device link local address, which now scales linearly to the number of devices I have. Okay, another interesting issue. Where is Jan? I know he loves renumbering case. He's not here, disappointing. So, renumbering case, you probably heard about that, right? For ISP environment, your CP reboots, gets another prefix via PD, your devices did not realize that prefix changed, and now you have old prefix and new prefix, and only one of them works. Surprisingly, we have the similar problem in the enterprise. Okay, let me go to my backup slides for this. Yes, so .1x. A desktop boots up, gets into, let's say, machine VLAN, right? Gets an address from blue machine VLAN A. Then a user comes to the office, logs in, .1x authentication happens, device moves to another VLAN, gets an address from another VLAN, the old address stays, right? Theoretically, indeed, the machine must be smart enough and realize that when .1x reauthentication happens, you need to do something with your network stack. I had this exact discussion with Microsoft support back in 2001 for IPv4. For IPv6, it's still the same. Network manager is total nightmare in this case. So basically, in half of the cases, what happens, right? You basically have two subnets on your interface, two addresses, and only one of them really works. However, there is a solution for this. Because again, this is a case which we never noticed until we got v4 off. There is a RFC for detecting network attachment, which says, like, if your device disconnects and reconnects, for example, Wi-Fi network, like layer 2 roaming, devices are kind of trying to do the right thing. Am I still on the same network? Do I need to completely refresh my network stack, or am I still fine using the old address? The first thing they all do, they check if my default router changed. If my link local and MAC address of my default router is still the same. Theoretically, after that, they still need to get a router advertisement and compare prefixes, but it's not all of them do that. So basically, a lot of devices kind of realize that when your layer 3 network changes, your router changes as well. However, if you use VRP, your MAC address is always depends on your group ID. And any reason to have more than one group ID? I'm just using the same number everywhere, right? Why would I have different numbers? And actually not so many of them, strictly speaking, it's just 256. Some devices also violates RFC and generates virtual link local address from its MAC address, which means that every network segment which uses the same VRP ID will have the same link local address and the same MAC address everywhere. Well, never been a problem, right? Until another renumbering case appears. I have two buildings, two different subnets, but they are too close to each other. When you walk from one building to another, you actually move between two subnets. But again, the same VRP ID everywhere, same link local, same MAC address. Device like, I'm definitely on the same SSID, same layer 3 network. I'm keeping old network config. As a result, nothing works, right? No connectivity. Yeah, people start complaining. What can we do? Oh, there is a solution, actually. Default address selection, RFC, says that when you select it, you have multiple addresses. It's fundamental thing in IPv6, right? If you have multiple addresses, you need to select which one to use. And there is one of the 8 rules says that if you have multiple routers and each router advertises you its own prefix, and you selected a router, please use the source address from the prefix advertised by that router. Makes sense for multi-homing, right? I have two ISPs, for example, right? I always want to send a traffic to ISP A from source address from ISP A address space. Mars people shall agree, right? So if host implements this, then all your renumbering cases are very easily solved. You're basically making sure that if you get a new prefix from a router, it should be different router, which means as long as every VLAN in my network has its own link local address. Basically, yeah, it sounds crazy, right? Globally unique link local addresses. Well, I don't know. I can probably make them city unique, but why bother, right? I just make them globally unique. What I'm doing in my network, because it's easy, I'm just using global/64 prefix as an interface ID for VRRP. Very easy to code, one line of code change. Works like a charm, I can tell you. So many people are now happy. So yeah, and I think it basically applies for CPE case as well, right? So as long as your link local address is a function of your prefixes, and by the way, rule 5.5, supported by Jan, you are late. I was talking about renumbering cases. I'm not going to repeat it. So rule 5.5, been supported by Microsoft for a long time. macOS supports this. And I know there is a work in progress for Linux, so we might actually get most operating system covered. So what other issues have we discovered? Going back to my favorite slide, 1 hour slide. So by the way, until recently, macOS was doing very funny thing. It was using 464xlat address, special one, and consider it to be a normal address because it's assigned on the interface, and it was sending MDNS packets from the source. Well, it freaked out some wireless devices because like, oh my God, it's a spoofed address, definitely, it's a bad client, I'll just block it and you're not getting on my network. It also makes VXLAN networks very, very, very unhappy because they see the given IPv4 address start moving between all ports in the network at the same time. CPU goes up to sky. Operational people are also unhappy. So basically, strictly speaking, the only issue you would probably see now is a cosmetic issue with traceroute, if you do traceroute from your MacBooks. And by the way, this network is using the same approach. So most of your MacBooks are probably V6 only right now. You probably would not see anything in traceroute, but this is work in progress. But besides that, yeah, so make this happen. We had to publish a number of RFCs to document that stuff. And thanks for open source community, right? That was implemented in various operating systems even before I was able to deploy it in my network. There are some ongoing work at V6 Ops at IETF to document stuff I was talking about, so feel free to read more details. For example, yeah, we're talking about how exactly to enable 464xlat, what should be criteria, when to enable it, when to disable it. So all operating system, all developers at least have some common guidelines. So next step for me, because as I said, I'm mostly done, famous last words, with Apple devices. Chrome OS, starting from 1.1.4, supports option 108. It's disabled by default. You can go into flags or settings, whatever it's called, and enable it. For Linux, you can again enable that stuff manually, but there is no 464xlat CLAT implementation in the standard package of Linux, so there is some work to be done there as well.